Function x on x plus 1, we should be able to get some early marks here. Now notice part A, okay? Notice part A, very easy to skip over that, all right, where it says draw the tangent. And so I've seen in more recent exams, and this is something I'm doing in my test as well, if it wants you to do something to the graph, we just put a row of boxes there, okay? So that sort of thing. Don't skip this part, because it just says part A and part B. And some people in the past have skipped part A because there's no box there. Okay, so draw the tangent, all right? So if you've got, I can't remember what the function looks like now, but you know, if you're drawing a tangent there, you just draw it as best as you can, okay? Just using a ruler, you get a mark for drawing a straight line. That's basically parallel at that point. Okay, part B, find f dash of x. Now we have one function on top of another. We need to use the quotient rule here. We'll have u is x, v is x plus 1, u dash is 1, v dash is 1. Okay, let's make a statement about f dash of x. U dash v, take u v dash on top of v squared. Okay, got the derivative function. Part C, find the tangent at x is not minus 1, plus 1 is it?
That x is 1, yeah.
X is 1, yeah. Find the tangent at x is positive 1. So for a tangent, we need two things. We need the point of contact and the slope, okay? When x is 1, the y value is going to be 1 on 1 plus 1. That's going to be 1 on 2.
Also says to show it in general form.
In general form. That's helpful. Thank you. Is that what it says? Show that the tangent. Yeah, it says show that the tangent is in general form. Okay. And the slope. Now, in order to find the slope, we've got the slope function already. This is it here, and we want to know the slope when x is 1. When I put the number 1 in here, I'm going to have 1 on 1 plus 1 squared. That's 1 on 2 squared. That's 1 on 4. That is the slope for the tangent. All right. Now we're using general form. Okay. So remember, from general form, if we have a on b, ax take b1. If we have minus a on b, ax plus b1. That's the equation of the tangent. Let's look here. We have positive slope, which means we're going to be using this circumstance. A corresponds with 1, B corresponds with 4. So we're going to have x take 4y equals c. And then in order to find c, we input the point of contact. So we're going to have 1 take 2 minus 1. Therefore, x take 4y equals minus 1. QED. Don't write it every time. Alright, on to D. Find the Y-intercept. Okay, find the Y-intercept of this tangent. Now the beauty about general form is you can see the x and y-intercept pretty easy. Y-intercept occurs when x is 0. So therefore minus 4y equals minus 1. Y equals minus 1 or minus 4. That is the Y-intercept. Okay, any questions so far? All right, so then I think it gives you this table, and it says, now, here's the tangents for different values of x. Find the y-intercept of these tangents. Okay, so we can rearrange. We can go y-intercept occurs when x is 0. So here we're going to have minus 9y is minus 4. Y is going to be 4 on 9. Here we're going to have 16y equals 9. Y is 9 on 16. Okay, this is quite a hard conjecture to see, but it's a bit of an easier one to prove. Alright, so when x is 1, we've got 1 at the top, and then we've got 4 at the bottom. When x is 2, we've got 4 at the top, and then 9 at the bottom. And when x is 3, we've got 9 at the top and 16 at the bottom. So perhaps one thing we can notice straight away is 1, 1 squared, 2, 2 squared, 3, 3 squared. That seems to be the number at the top. So if we're talking about the tangent at x is a, perhaps the number at the top is going to be a squared. Okay, that seems pretty clear. And then the number at the bottom, okay, here we've got, well, 2 squared, 3 squared, 4 squared. It's just the next integer squared, the next consecutive integer. So it's a squared on a plus 1 squared. That's quite tricky to see. All right. But once I've written it there, you can see it pretty clearly, see the relationship. Yep. If a is 1, we have 1 squared on a plus 1 is 2, on 2 squared. If a is 2, we have 2 squared on 2 plus 1 is 3, 3 squared is 9. So there's the one. Okay, now prove it. Prove that the y-intercept for the tangent at x is a is this. Okay, so we need to find the equation of the tangent. Find the equation of the tangent at x equals a. That's the general case. At any value of x, what is the equation of the tangent? So for a tangent, we need two things. We need the point of contact and the slope. Now we're talking about x is a. Okay, so the x value is a. The y value, what's the function? X on x plus 1. So the y value will be a on a plus 1. Okay, the slope, we've already got the slope function. That's this one here. So the slope then is going to be 1 on a plus 1 squared. Alright, so we've got the point of contact, we've got the slope just by substituting those into the function and the derivative function respectively. Alright, we've got everything we need to find the equation of a tangent. The tangent is y equals mx plus c. M is 1 on a plus 1 squared. And then we will substitute in the point of contact. We're going to have a on a plus 1 is the y. The x value here is going to be a. Plus c, sorry. We'll get c by itself. C is going to be and very, very close. Okay? So let's think about what's it asking us to do. I mean, let me state the equation of the tangent first, just for the sake of argument. We've got 1 on a plus 1 squared times x plus c. This is c. There we go. That's the equation of the tangent. Now it says, show, we're proving that the y-intercept is this. Okay, so if we consider our tangent over here, this is our y-intercept, right? So we've got to collect it somehow. We've got to make them the same. So if we have a on a plus 1, take a on a plus 1 squared. In order to perform this operation, they need to have the same denominator. Now we don't need to cross multiply. We can just multiply this one by a plus 1 on a plus 1. Okay? We're not changing its value, we're multiplying it by 1. And then the denominators are going to be the same, so we can perform it. Okay, so let's go through that. We're going to have a squared plus a, take a on a plus 1 squared, which is a squared on a plus 1 squared. Now you can write Q again. Okay, so that was a little bit easier just because there's only one part to it. Find the equation of the tangent, state its y-intercept, okay? Now, with these problems, okay, so I've gone through that with you, and I'll go through a number more together. Next lesson, we will have a booklet on them. With these problems, all right, it's good to sort of just try them, okay? Even if you don't know what to do, you learn a lot more from trying things and sort of confronting the unknown than you will from me just showing you how to do it, okay? I can show you and you can understand this one, but if you're confronted with it, you're sort of in the deep end, you've got to think, how am I going to solve this problem? They're the skills that you want to develop, because I can show you all of the questions I've got, but still there's lots of different ways of asking things that you're just creating new ones. So really encourage you to have a go at some of them. And with these questions as well, you just want to get as many marks as you can. Alright, so it's just about getting as much on the paper. Even if you don't get the proof and you don't know what to do, what are we doing? It's a general case. What's the general case? Alright, are there any questions? Excellent. So, yeah, try and finish off 3A for homework.